Many memory foam formulations look perfectly fine in lab trials. The rise is smooth, the structure looks acceptable, and there are no obvious defects after cutting. But once moved onto the production line, problems start appearing quickly: closed cells, cracks, collapse, sinking, coarse cells, compression marks, even internal decay. At this point, many people immediately go back to the formulation. But in many cases, the real issue is not the formulation itself, but misjudgment or poor control during production. Memory foam reacts more slowly and has a narrower process window than regular foam. Fluctuations that regular foam can tolerate may easily turn into structural defects in memory foam. Take closed cells, for example. They are very common in memory foam. In manual foaming, if the corners of the foam feel hard after demolding and show a pressurized sensation when squeezed, it usually indicates closed cells. This is often related to a tin-heavy system or insufficient cell opening effect. If the surface cures too fast, the system may be too gel dominant. If it cures too slowly, the opening system may be too weak. But the key is being able to identify which type of problem you're dealing with. Cracking is another example. Memory foam cracks usually appear in two forms: horizontal plane cracks and vertical line-shaped cracks. Horizontal cracks are often related to insufficient late-stage gel strength. The foam opens well, but the structure cannot hold during curing. Vertical cracks are more commonly linked to poor mixing or insufficient mixing time, leading to localized reaction differences. In some cases, low isocyanate levels may also reduce structural integrity. Collapse is another common issue. Sometimes it's simply caused by a missing or insufficient key additive, such as silicone or tin. Sinking is different. The foam may look normal at first, but gradually sinks as the reaction proceeds. This often occurs when the silicone system is operating near a critical window. Some defects only appear after cutting, such as coarse cells, compression marks, or internal decay. Coarse cells may relate to opening agents, isocyanate level, temperature, or mixing conditions. Compression marks usually indicate poor mixing. Internal decay with long-lasting tech often points to incomplete reaction due to poor mixing. These problems may not show up in lab trials, but once continuous production begins, they often appear together. So the real challenge in scaling memory foam is not just the formulation, but the ability to correctly judge on-site phenomena and apply the right adjustments. In the next episode, we'll explain why memory foam is much more sensitive to equipment and process control. If you'd like a clearer overview of common defects that appear in memory foam production, comment problems below and we'll send you the reference document, 20 Common Defects in Memory Foam Production.